The universe is an endless fractal, made basically out of an endless number of inestimable blasts known as minimal large bangs. On the off chance that you consult a science course reading published before 2006, you will see that Pluto was included as one of the 9 planets in our solar system. However, this is no longer the case. Nearly a decade ago, the International Astronomical Union, IAU, redefined Pluto's status and excluded it as a planet. Now, the IAU is again discussing this issue since NASA has provided clear pictures of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our planetary system to explore the first images of Pluto in our history. If you're interested in staying up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, but the vastness of space presents many unanswered questions. This is where NASA's groundbreaking James Webb Space Telescope project seeks to discover its own universe. This great venture builds on NASA's past missions, and there is great interest in interpreting extraordinary discoveries from ancient times. We are understandably curious to learn more about the Big Bang and how our solar system came to harbor life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our planetary system, revolutionizing our understanding. Although it is important to find out if we need to look back for definitive answers about our universe, and perhaps reconsider them, the Pluto question has been the subject of contention in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it has provided, we have more and more data to explore our nearby planet system. It seems that the $10 billion investment in NASA has led to a revision of science textbooks to include all that we know about Pluto. This time, it is likely to regain planet status. Here's why. Our knowledge about Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and renewed capabilities of the James Webb that have provided the pictorial evidence needed to strengthen our theoretical understanding of this putative planet. Although past observations classified which objects are considered planets and which are not, the IAU had little solid data on which to rely. The criteria used for this classification may have been sketchy. After the decision in 2006, 2 different scientific scenarios on the issue arose. Some believed that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly adopted the new non-planetary status. Most space pioneers have remained uncertain on the matter. However, due to the captivating revelations of the James Webb, the question of Pluto's status remains. The first sharp pictures of Pluto provided by NASA are revising our understanding of cosmic history. The first and primary human encounter with Pluto was conducted by the New Horizons mission, which has been in progress for many years. In July 2015, the mission achieved its goal by passing close to Pluto and its many moons. This was the first time humans had the option to get a close look at the space artifact and gather the most comprehensive data set to date about its moons and surface. The New Horizons mission opened up great opportunities for NASA in its exploration of the Kuiper Belt, a deep region of space. The primary achievement of the mission was the detailed investigation of Pluto, now viewed as a dwarf planet, and its largest satellite, Charon. It also managed to capture clear pictures of the 4 other satellites known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission gathered data, including the encounter with Pluto and Charon, amounting to 6.25 gigabytes. What does this data mean for NASA according to the dwarf planet? First, the findings were so notable that scientists had to develop new data models to better comprehend Pluto's surface and environmental conditions. It was found that the dwarf planet was undergoing significant changes in its surface and atmosphere. It was certain that Pluto was far from being a dormant body. It was evolving at a rate that surprised NASA and challenged what was previously believed about this putative planet. The New Horizons mission was groundbreaking, and its encounter with Pluto occurred nearly a decade ago. Since then, the field of space exploration has seen dramatic improvements through technological intervention. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One might even say that we are getting increasingly closer to a complete understanding of our nearby planet system. However, there is an issue with missions like New Horizons and any decisions to explore planets farther from the Sun. The issue lies in the prioritization of resources. Investing millions to examine a scientifically significant planet might raise questions about the existence of possible living things elsewhere. Why head to the edges of the nearby planet system? These are challenging questions, to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the exploration of Pluto, but it also sparked our interest in further exploration beyond known limits. In the case of Pluto, its study is fundamental to building a broader scientific understanding of other small planets. Despite lying in a cold, dark region of the universe, the primary pictures of its surface proved groundbreaking enough to reveal that Pluto is an active object in our nearby planet system. As they say, a picture is worth 1,000 words, and these crystal-clear pictures from NASA furnish us with valuable information. First, Pluto was found to have a heart. Most land phenomena on this dwarf planet are driven from its core, scientifically known as Sputnik planum. Surprisingly, it turns out that Pluto literally relies on its heart. A quick glance at NASA's high-resolution pictures revealed that this heart is a white, cold, and nearly frozen region. The left ventricle of Sputnik's heart resembles a massive nitrogen glacier spanning thousands of square kilometers. Another remarkable geological feature of Pluto's surface is that its rotational axis has undergone significant reorientation. What researchers call a precession process was previously unknown to NASA before the mission. The dwarf planet's bowl is in the opposite position than expected. This reorientation has significant implications for understanding the dynamics and development of Pluto as a planet. In simple terms, the tidal pivot between the moon Charon and Pluto is being affected by Sputnik planum, the heart of the dwarf planet. This influence has reoriented Pluto so that its bowl is more closely aligned with a tidal pivot, something that was not previously known. We have always known that this ancient planet is challenging for obvious reasons. However, what was not known is that Pluto's icy surface also causes a tilt due to the imbalance in its mass. The core of the dwarf planet is a 4 kilometers thick layer of ice, which is quite likely contributing to that epic mass. When combined with tides, this process can cause the reorientation of the planet's rotation axis in search of balance on its own circle. However, the ice sheet alone is not adequate to generate a steep reorientation point or to produce significant levels. As we mentioned earlier, technologically supported investigations can alter our cosmic history, and this is just such a moment. Researchers have also found that Pluto is a world with an ocean of its own beneath its thick ice sheets and ice-covered surface. Pluto's interior contains a vast ocean that also impacts the reorientation of its pivot hub. This discovery is exceptional for multiple reasons. However, most importantly, because it completely changes our understanding of the planet. The highly likely presence of an ocean in Pluto's crust means that we will have more information about its origin and how it formed. The discovery of an ocean beneath Pluto's icy surface has ignited new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth and prompts us to reconsider the dynamics of celestial bodies in the distant reaches of our nearby planet system. This ocean, speculated to exist based on gravitational data and now strongly supported by the New Horizons mission's findings, represents a potential reservoir of liquid water beneath a frozen exterior. Understanding Pluto's geological processes is crucial to understanding its evolution over billions of years. The dwarf planet's surface features, including its distinctive heart-shaped region and the unexpected reorientation of its rotational axis, provide enticing insights. Sputnik planum, the heart's left ventricle, acts as a remarkable geological component. It's believed to be a large basin that may have formed due to a subsurface ocean freezing and causing the surface to collapse, or perhaps due to an impact that unearthed material, leaving a deep depression. The New Horizons rocket's encounter with Pluto in 2015 revealed a dynamic world, far from the cold, inactive body it was once thought to be. The mission captured detailed pictures of Pluto's diverse landscape, including mountains made of water ice, vast plains of nitrogen ice, and regions with complex patterns resembling cell networks. These features suggest active geological processes, possibly driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, although thin compared to Earth's, plays a significant role in its surface dynamics. It consists primarily of nitrogen, with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating temporary atmospheres that shift with seasonal changes. Understanding these atmospheric processes helps scientists recreate Pluto's atmospheric history and its ongoing evolution. The New Horizons mission's discoveries extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, showed an unexpectedly diverse landscape, including a massive canyon deeper than the Grand Canyon and a dark region nicknamed Mordor for its distinct coloration. Other moons, such as Hydra and Nix, showed irregular shapes and cratered surfaces, indicating a history of impacts and geological activity. NASA's exploration of Pluto and its moons exemplifies humanity's ongoing